Welcome friends to my YouTube channel. Today we are going to solve a certain question under dynamics. But before we get into that, try to subscribe to my channel if it's your first time viewing the videos. Try to share the videos and also comment for more videos. So the question goes like this. They're saying a horizontal force of 500 newtons pulls the two masses of 10 kg and 20 kg lying on a frictionless table connected by a light string. All right. Calculate the acceleration of the two masses and the tension in the string. Okay. So what we are going to understand the most is if you apply a force at this given point, the same force we are going to apply to this object. So since this object and that one, they are connected to the same string, meaning that they're going to be moving with the same acceleration. So remember, tension here appears to be an internal force, meaning that once you apply a given force of 500 newtons, which is connected to this, it is also going to be applied to the same 20 kg, which is located at that given position, due to the fact that in the needle we have an internal force which connects the two strings. So how do you calculate the same acceleration? Here basically we are going to use the second law of Sir Isaac Newton's, which says acceleration has to be directly proportional to um, acceleration has to be directly proportional to the force applied, provided the mass is constant. All right, so let's try to understand what is happening here and what formula are we supposed to use. Okay, so using the second law of motion, which says the summation of forces in x, since the objects that are moving in the horizontal direction, meaning that they're moving in the x-axis. So I'll say the summation of forces in the x-axis, we are going to get acceleration. So basically we have two masses here. We have two masses, M1 and M2. I'll label them as M1 and M2. So what am I supposed to do if I reach at this given position now? Where there is mass here, that's where you're going to put the summation of two masses. Where there is a force, the summation of forces in X, we only have one force which makes it move forward. So what we are going to do, we are going to have the force, it has to be equal to, where there is mass, I'll say M1 plus M2. Remember, I'm saying acceleration is the same. So we are going to write it like that. Then you divide throughout by M1 plus M2. Even here we'll say M1 plus M2. I'll divide those, having acceleration remaining. I'll say equal to, we're going to get force over M1 plus M2. All right, now what are we supposed to do at this instant of time? We are going to understand it to say the force which is being applied to a given position, which is this one, is 500 newtons. That's what I'm going to write on top, 500. I'll divide this by this one. We have two masses here. We have M1, which is 20 kg. M2 has been given as 10 kg. So we're going to have 20 plus 10 kg. Acceleration will be equal to 500 divided by, whenever you add those two, you're going to have 30. So I can remove this 0 and that 0, having 50 divided by 3. So the moment you punch, you say 50 divided by 3. What answer are you getting? Acceleration here is giving us 16.67 meters per second. Right, that's how we do calculate for acceleration, as simple as that. Remember, tension acts as an internal force. So the moment you apply the force to one object, meaning that the same two objects, they're going to be moving with the same acceleration. Why? Because they're connected by a certain force as the internal force in between. Now we come to the issue of tension. How do you calculate for the tension? So to calculate for tension, it is also very simple. What we are going to do, I'll isolate the two objects and know what force makes this one move and what forces makes this one move and which force is trying to oppose. Under dynamics, we are saying you draw the forces away from the object. You don't draw a force towards the object. What does it mean? I'm going to draw two free body diagrams separately for this one and that one. Remember, we don't have friction force here, meaning that we are going to know the forces that are being acted on these two objects and find the tension using the same two forces. So what we are going to do, the moment you isolate these two objects, we are going to have something like this. This is my M1. I'll also have something like this. This is M2. So we need to understand to say, if you come to M1, what force makes it move? We only have the tension which is in the middle and it is connected to this one. So I'm going to draw my tension away from this object. It has to be facing in that given direction. I'll say T. All right. Here we don't have T1, T2 because tension is the same tension which is connected between the two objects. What next are we supposed to do? The moment you come to this one, what you are going to understand is this force is moving in this given direction. But there is tension which is also moving in the opposite direction as it is trying to be connected to that. In short, you can't write tension again to be pointing towards this if you are dealing with this object. You have to make sure that you make this tension move away from the object. Here for this one, it has to point in this given direction. I'll say tension. We also have a force, which is a 500 Newton force pointing in that given direction, right? So what are we supposed to do? Here they want us to calculate for what? For tension. Remember, I'm saying acceleration is the same, meaning that you say the force which makes this one move, it has to be equal to acceleration, and we are going to have tension has to be equal to mass multiplied by acceleration. That is according to this object only. If you come to this one, we have the applied force which is moving towards the positive side. Then tension is moving in the opposite as it is being connected to that object. What are we supposed to do now? I'll say the forward force, or in short, summation of forces in X has to give us acceleration, which is ma. Where we are here, things are going to be simplified like this. We have this force which is moving forward. The meaning of summation simply means the total sum of forces in X must give us acceleration. So since the forward force is the one which makes the object, the whole lot of these two objects move, it has to carry a positive acceleration, and we are going to write it like this. I'll say force, this. Then tension is opposing, it is moving away from the object in the opposite direction to the applied force. It must carry a negative acceleration. I'll say T. We are going to get mass multiplied by acceleration. So remember, we have two masses here. The mass for this one, I'll label it as M1. The mass for that one, it has to be M2. So you can use whichever. You can either use this or that, still we are going to get the same tension. So long you remember that acceleration is given as that one. So since this one, we are saying the mass for this one is 20 kgs, meaning that my tension here has to be equal to, we say 20 multiplied by the acceleration, which is 16.67, like this. Then we'll come here, say 20 multiplied by 16.67. We are getting the tension as 333.4 newtons, meaning that tension for this one has to be equal to 333.4 newtons. For this part, we are done. If you use this one, still you have to get the same tension. Why? Because we have this, which is 500 newtons. We also have this part whereby you can just plug in the values. But you need to remember that this is 10 kgs. and that one is 20 kgs. So what we are going to do, I'll write it like this. I'll say force minus tension. It has to give us m2 multiplied by acceleration. Then what we are going to have now, we can interchange these. This will replace the position for that, and this one will come here. So we are going to have force minus m2 acceleration. We have to get the tension. So at this instant, we'll say tension has to be equal to, what is this force? The same applied force for this one, which makes the entire system move. It has to be 500. What is this mass? We are saying this has to be 10. Acceleration 16.67. So what I'm going to do, simple calculation that we can have here, we are going to have 500 minus, I'll say open, 10 multiplied by 16.67. Now close. We are also getting 333.3. So due to some sorts of rounding off here, that's why we are able to get something like the decimal place is almost different from that. So we are going to have the tension, which is equal to 333.3 newtons. So you can choose whichever. You can either use this one or that one, and you'll be able to find the tension just like that. Thank you for watching.